All right, class. So right now we're going to look at 3 problems from section 5.2. All right, we're going to be looking at some mean, variance, standard deviation, all that stuff. So let's look at the first problem. All right, so it says, from past experience, a company found that in cartons of DVDs, 90% have no defects, 5% has 1 defect, and then 3% contains 2, 2% contain 3 defective DVDs. Find mean, variance, and standard deviation. All right, so what we're going to do is construct the probability distribution here. Okay, let me see if I can. Let me erase this real quick. All right, so we're looking at x and p of x. So we can have 0 defects, 1, 2, 3, and that's about it. All right, so for 0, there is a 90% chance of having no defects. Then we have 0.05, 0.03, and then 0.01. All right, so that should add up to 1, which means that this is a probability distribution. So now let's go ahead and do the mean. So let's go ahead, let's set up the 3 or the columns. All right, so x squared, that's going to be 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. We're going to set up the x times p of x. So in this instance, we have 0 times 0.9 is 0, 1 times 0.05 is 0.05, 2 times 0.03 is 0.06, 3 times 0.01 is 0.03. And then we have, let's see here, we have x squared times p of x. So we have 0 times 0.9, 0, 1 times 0.05, 0.05, 4 times 0.03 is 0.12, 9 times 0.01 is 0.09. Alright, so it looks like we have the various values here. So now we're going to go ahead, I'm going to go ahead and go ahead and make this a little smaller. Okay. All right. All right, that's better. Okay, so now we want to find the mean, so we got to add this guy up. So the mean is going to be when we add this. So 0.05 plus 0.06 plus 0.03, that's going to be 0.09, so this is going to be 0.14. Alright, now we got to add this up. So sigma x squared p, so that's going to be 0.21, so that's going to be 0.26. Alright, so now we got the mean, so that's done. We need the variance, so we got to do sigma squared equals this guy, 0.26, minus the mean squared. Alright, so we got to do that on the calculator. So we got 0.24 approximately. Alright, because 0.14. Okay, so yeah, that's right. So now we got to do the sigma, which is going to be the square root of 0.24. Which is approximately 0.49. Alright, and that's going to be our standard deviation. So that's it for that guy. So we are done with number 1. I'm going to go ahead and move on to number 1. Now we're going to skip to number 5. So we got a lottery offers $1,000 prize, one $500 prize, and $500 prizes. 1,000 tickets are sold at $3 each. Find the expectation. So we're going to set up our probability distribution. Okay, so we got, what are our options here? Well, we're buying the tickets for $3 each, so there's a chance that if we buy one ticket, we're going to be short $3. What are the chances of that happening? Well, there's one ticket here, there's one $500 prize, and then $500 prizes. That's a total of 7 tickets. So 7 tickets are winners, which means that 1,000 minus 7 are losers. So we got 993 out of 1,000 tickets are going to be where we lose $3. So we can also have the option of winning $100, but then paying $3, so that's $97. What's the chances of that? Well, there's 5 tickets that have that. All right, so 5 out of 1,000. All right, we can also pay $3 and then win $500, so that's $497 winnings. There's only one way of doing that out of 1,000. We can pay $3 and get $1,000 back, so 997. One way of doing that. So we can calculate our expectation, which remember that's the same thing as our mu. So we're going to multiply x times p of x. Alright, so we got to do -3 times that, 97, 497 times 1 out of 1,000. Alright, and then we're going to calculate that, and that will give us our expectation, or expected value. So here, this will give us negative 2,979 out of 1,000. 97 times 5, that's 194 out of 1,000. We got 497 out of 1,000. And 997 out of 1,000. So we add those together, 997, 497, and we get, let me go ahead and move this, negative 1,291 out of 1,000. Alright, so this is going to be negative 1.291, which is about negative $1.29. Alright, so that means that on average you're expected to lose $1.29 from this game, which is not very fair. So this is not fair. Alright, so this is not a fair game. Sometimes they'll ask you if it's a fair game or not, and so we know that since it is not equal to 0, it's not fair. Alright, so the last problem, we have a life insurance example. So a woman purchased $100,000 term life insurance policy for an annual payment of $360. Based on a period life table for the U.S. government, the probability that she will survive the year is given by that. Find the expected value of the policy for the insurance company. Alright, so we got probability distribution. There are basically 2 options here. She lives and she has to make the payment, right? So she has to make an annual payment of $360. So she is short $360, but she gets to live. Alright, so that's a good thing. So we got, that is the chances that she will survive. The other option is, well, her family gets the money, but she doesn't live, right? So her family, so basically she gets the $100,000 minus, okay, so actually we're just going to say she gets the $100,000. And we will actually subtract that by, let me subtract that by the payment that she makes. So $100,000 minus $360. So that's 99,640. All right, this is assuming that she pays it. If she doesn't pay it, then it's going to be $100,000. Then she'll get the full $100,000. But I'm just assuming that, there's a payment that's made automatically, by the time, she ends up not surviving. But if in the event that she doesn't make the payment, it should be $100,000. All right, so in this case, in either way, it's going to be the probability that this happens is 1 minus that guy, which is very small. All right, so we got to do 1 minus 0.999057. Let's go ahead and figure out what that is. 1 minus 0.999057. So it's 0.000946. So very small chance of that happening. She is a young woman. She's 35 years old. So there's a very small chance that she won't survive the year. All right. So the probability, or the expected value, we're going to go ahead and multiply the two things together. All right, and actually, guys, I'm going to change this number. I think the problem assumes that she won't make the payment, so she'll get the $100,000. So I apologize for that. So we will leave it as $100,000. We assume that she can't make the payment because she doesn't survive. So I will change that. All right, so now we're going to go ahead and do this, and we will figure out on average whether she gains or loses. $100,000 times. Okay, so it looks like we have negative $265.06 approximately. So it looks like she's losing an amount equal to negative $265. So this is what she is losing. Now we know that the insurance company is gaining this amount. So find the expected value of the policy for the insurance company. So in this case, the insurance company is getting $265. So this is for her. Now for the insurance company, they are getting positive $265.06. All right. So since they're talking about insurance, this makes sense because for insurance, they want to get money. They don't want to lose money. So they won't give you an insurance policy unless they're sure they're going to make money out of it, which means that you have no pre-existing conditions, and there's a very small chance that you will croak at the end of the year. So this value makes sense.